All right, this is AP/BC Calculus. We are doing a BC only section. This is Unit 10, Section 8, the ratio test for convergence. So this is super duper 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 important. Please, please, please learn the ratio test because it's going to come up for sure, 100%. All right, so suppose that you have an infinite series a sub n, right, that you're summing, and you want to know if it converges or diverges. What you can do is you can do the limit as n approaches infinity of the nth plus 1 term, that is a sub n plus 1, over the nth term, which is a sub n. Excuse me. If that limit, if the limit of that ratio is less than 1, the series converges. If it's greater than 1, the series diverges. And if it's equal to 1, the ratio test is inconclusive, so you'll have to move on and do another test. So big hints on when to use the ratio test. If you've got factorials, it's a ratio test problem. If the series involves exponentials, like a numerical base with a power involving n, probably a ratio test. If the series involves a variable like x, so let's say you have, 2 to the n times the quantity x minus 1 to the n, etc. If there's a variable in that series, then you're pretty much using the ratio test, and we'll talk more about that in 1013. And then just genuinely, honestly, you're going to use this a lot, so please put the time in to learn the ratio test. It's really up there in terms of importance. All right, so we're going to apply the ratio test. There are 3 possible answers: converges, diverges, or the ratio test is inconclusive, right? Because we're not doing other tests here. Right now, we're focusing only on the test I asked you to do. In reality, as we saw at the end of, I think, the 10.6 video, if you're just given a bunch of series and asked which converge or which diverge, you're going to have to go through this whole checklist in your head, and we are going to do that in a later video. But for right now, I want you to focus on the test that we're working on so that we get some practice. So I'm going to apply the ratio test. So I want the limit as n approaches infinity of the absolute value of the nth plus 1 term is going to be 4n plus 1 times an n plus 1 to the third over an n plus 1 factorial. Okay, so that's my a sub n plus 1. And my nth term is just going to be this exact term the way it's written. So 4 to the n to the third over an n factorial. Okay, so now I'm going to have to clean this up, and I want to show the relationship of this quantity to 1, but I need to clean this up first. So I get that this is the limit as n approaches infinity. Inside the absolute value, I'm going to get, so I'm going to intentionally write things a little bit different. All right, so here's my blue thing, right? Actually, let me do this. I'm going to not skip ahead to the way I would do this yet. I mean, I'm going to do what I would do, but I'm going to try not to take it in too many steps because I know that this is our first ratio test problem. Okay, so I have the blue fraction, right? And then when I divide by the red fraction, it's the same as flipping and multiplying by the reciprocal. So I'm going to get an n factorial on the top, a 4 to the n on the bottom, and an n cubed. So what I want you to notice about this is everybody has a matching buddy on the top and bottom that is basically the same function, but just with a different n value, right? So I have this, let's clean it up a little bit. So I have this 4 to the n plus 1. I have an n plus 1 quantity cubed, and I have an n plus 1 factorial. Now what I've done here is I'm intentionally writing it in an order so that on the bottom I have a 4 to the n. Well, I'm going to line that up so I can see that that's got a matching buddy. I've got an n cubed that goes with the n plus 1 quantity cubed, and I have an n factorial here. Okay, so let's see what happens if I clean this up. Well, when I clean these guys up together, I just get that that's a 4, right? So I get that this is a 4, because this would be 4 to the n plus 1. This is a 4 to the n. I subtract the exponents, I get a 4, right? When I clean these guys up, right, I'm going to get a 1 over n plus 1. And actually, let's just, let's hang on. Okay, I'm going to get, so when I clean these guys up, we'll actually deal with these guys first. This thing, so that's a 4 over 1, this thing is going to be an n cubed plus a bunch of stuff when I FOIL it out over an n cubed, right? Technically, this is an n cubed plus a 3n squared plus a 3n plus 1 because I know my Pascal's triangle, right? But I don't actually care what it is. And this guy, when I clean up, this is an n times n minus 1 all the way down to 1. This guy is an n plus 1 times an n minus 1. So what's going to happen all the way down to 1 is these guys cancel, and I get that this thing's just a 1 over n plus 1. So the reason that's relevant, that I really only care about this n cubed, like I don't really care about this stuff, I care about the n cubed, is because we're approaching infinity. So what this is going to look like as I approach infinity, essentially, is a 4 times, the top is going to be an n cubed, right? And if you want to leave it this way, you can, but what matters is that it behaves like an n cubed, right? And the bottom is going to be an n to the an n to the fourth plus an n cubed, which means it's an n to the fourth. So this thing is approaching 0, which is less than 1, right? Because the top, right, the top is an n cubed, the bottom is an n to the fourth. The bottom is a bigger power, so so essentially this thing approaches 0. So this thing converges because, again, I'm looking for a value that is less than 1, meaning convergent. A value greater than 1 is divergent, and a value equal to 1 would mean that we don't know, right, that it's inconclusive. All right, so let's try this again. We're going to set up a ratio test. This is the limit as k approaches infinity plus 1 over a k plus 1 factorial, right? That's my k plus 1th term. And on the bottom, I want 2 to the k over a k factorial. You should set it up as a ratio even if in your head you're able to kind of skip to the next step, right? You should show the ratio because it's very likely to be one of the points on the AP that you set it up as a ratio. So notice the k factorial ends up on the top and the 2k ends up on the bottom, or 2 to the k rather. So if I put these things in a slightly better order, right, k approaches infinity, this is going to be a 2 to the k plus 1 over a 2 to the k, which we'll deal with in a sec, right? That's these guys. And then this is going to be a k factorial on top of a k plus 1 factorial, which, again, you want to kind of get comfortable using, right? So what's going to happen? These guys together, the green ones together, are just going to become a 2. Right? This is k approaches infinity. This is just going to become a 2 because it's 2 to the k plus 1 minus k, which would just be 2 to the first, right? And then this thing's just become a 1 over k plus 1 because really, just as a reminder, k plus 1 factorial means k plus 1 times all of the terms below that, which would be k factorial. So I'm going to get that this is a 0 again, which is less than 1, so this thing converges. All right, let's go ahead and try the ratio test again. So the limit as k approaches infinity of my k plus 1 term will be 9 to the k plus 1 over, and this one's a little bit tricky, right? This is going to be a 2 times a k plus 1, all inside the factorial. On the bottom, I have a 9 to the k over a 2k quantity factorial. You can't make that a 2 factorial times a k factorial. That's not how factorials work. So this is the limit as k approaches infinity of a 9k plus 1 over, so this is a 2k plus 1 inside the factorial, so, or sorry, 2k plus 2 inside the factorial, and then multiplied by the reciprocal of this, this is a 2k factorial over a 9 to the k. All right, so limit as k approaches infinity of, if I reorganize this a little bit, I'm going to get 9 to the k plus 1 over 9 to the k. And then this is going to be a 2k factorial over a 2k plus 2 factorial. And we'll talk about that in just a sec. So this one's easy, right? This one's easy. This is just a 9, right? So this is a 9. This is the limit as k approaches infinity of, this guy's a 9. This one's a little bit trickier. When you look at this one, so 2k factorial is on the top. On the bottom, 2k plus 2 means a 2k plus 2, a 2k plus 1, and then a 2k factorial the rest of the way down. These guys cancel, and I end up with this 2k plus 2 times 2k plus 1. It doesn't really matter in this instance because honestly, as my k's approach infinity, I'm going to get a 0 again. This thing converges. All right, go ahead and give this one a try. You have an e to the 4n and you have an n minus 2 factorial, right? So the limit as n approaches infinity of my nth plus 1 term is going to be e to the 4, and then I need to plug in an n plus 1, which we're going to clean up in a sec. On the bottom, it's going to be an n plus 1 minus 2 inside the factorial. And then my other term, my a sub n, is really just me recopying the a sub n that was given to me, right? And we'll deal with that in a sec. All right. So this seems to be the limit as n approaches infinity of, so this is an e to the 4n plus 4 over n plus 1 minus 2 is an n minus 1, right? And then multiplied by this reciprocal, this will be an n minus 2 factorial over an e to the 4n. All right, so if we clean up my stuff and put things that are sort of matching types of terms together, I have an e to the 4n plus 4 on top and an e to the 4n on the bottom, right? I have an n minus 2 factorial over an n minus 1 factorial. So let's clean them up. These guys together end up just being an e to the fourth, right? Because it's 4n plus 4 minus 4n. So this is going to be an e to the fourth. And then this guy, right? So n minus 1 is the larger number, right? Because n minus 1 is an n minus 1, n minus 2 factorial. So these guys cancel, and I end up with a 1 over n minus 1. So I end up with an e to the fourth over something infinitely large, which is a 0, right? So that is less than 1, and this thing yet again converges. They're not always going to converge. It's just that the ones we've had so far have converged. All right. So go ahead. We're going to go ahead and try the ratio test again. So we're going to do the limit as n approaches infinity of, so my a sub n plus 1 term is going to be a 3 to the 1 minus 2 plug in an n plus 1 over an n plus 1 quantity squared plus 1. And then my a sub n term is just exactly what's written here. So 3 to the 1 minus 2n over an n squared plus 1. Right. Okay, so that's going to equal the limit as n approaches infinity. Okay, so we get, if I clean this up, this is a minus 2n and a minus 2. So I think I get e to the, sorry, not e, 3, my bad. 3 to the negative 2n minus 1. Over, and I'm going to leave this as an n squared, or sorry, as an n plus 1 quantity squared plus 1 for a sec. We can clean it up in a sec if we want. So n plus 1 squared plus 1. And then when I flip this guy, this seems to be an n squared plus 1 over a 3 to the negative 2n plus 1, right? Clean that up there. Okay. So I get that this is the limit as n approaches infinity of, so if I put the 3 to the negative 2n minus 1 on top of a 3 to the negative 2, oh, sorry, the minus 1 is in the exponent. Come on, brain. Minus 1 on top of a 3 to the negative 2n plus 1. We'll deal with that in a sec. Here I have an n squared plus 1 over, and I could FOIL this out. And I'm going to talk to you in a second about why I'm not going to, but I could, right? So these guys, right, when I clean these guys up, I'm going to get an exponent that is a 3 to the negative 2n minus 1 minus a negative 2n plus 1, right? That's what would happen if I subtract these exponents, right? So I'm going to end up getting that this, when I distribute, means the n's cancel, and I'm pretty sure I get that this thing is a 3 to the negative second, right? That's what that ends up being. So the limit as n approaches infinity of a 3 to the negative second times, and then these guys, right? The top is an n squared. If I FOIL this out, if I FOIL it out, I'm going to get n squared plus 2n plus 1 plus 1, but all I really care about is that this is also an n squared. Like, I can logically intuit that I get an n squared over an n squared. So this is an n squared. If you want, right, if you want to make this n squared plus 2n plus 2, you certainly can. But really, since you're approaching infinity, all you care about is what the leading coefficients of those would be. So I get that this thing is a 1/9 times a 1, which is 1/9. Since that's smaller than 1, this thing converges. All right, so we're going to go ahead and try the ratio test again. The limit as n approaches infinity of, so my nth plus 1 term is going to be 2 times the quantity n plus 1 plus 3, all inside a factorial, over an n plus 1, quantity squared, all over this nth term. So 2n plus 3 factorial over n squared. Okay, when I clean this up, I'm probably going to start by making this a 2n plus 2 plus 5, so plus 3. So this is a 2n plus 5, right? That's what this whole inside is. So I get that this is the limit as n approaches infinity of a 2n plus 5 factorial over, and I'm going to leave it as an n plus 1 squared for now because I don't really care. And then when I flip the denominator, this is what happens. All right, so let's clean it up a little. This is the limit as n approaches infinity of a 2n plus 5 factorial over a 2n plus 3 factorial times an n squared over, and again, you could FOIL this out if you want. It's n squared plus 2n plus 1. Really, all we're going to care about is recognizing that the leading coefficients, like these guys, as n approaches infinity, these guys are going to be a 1. For these guys, remember that 2n plus 5 is the larger numbers. This is 2n plus 5 times 2n plus 4 times 2n plus 3 all the way down to the bottom, which would mean these cancel. So I'm going to get that this is the limit as n approaches infinity of a 2n plus 5 times 2n plus 4, my bad, times this thing. So what's going to end up happening is that this is going to be infinitely large because the power on the top, right? So if you clean this up, the power on the top is going to be a 4n to the 4th, right? So the top is going to be a 4n to the 4th, right? Because 2n times n cubed, it's going to be a 4n to the 4th plus a bunch of stuff. I don't really care about the stuff because we really care about leading coefficients. And the bottom is going to be an n squared plus a bunch of stuff. Well, what that means is that this thing is getting infinitely large. This limit, the limit as n approaches infinity of this ugly monstrosity, right? The 2n plus 5 times 2n plus 4 times an n squared over this thing is infinitely large, which is very much greater than 1, so this thing diverges. And that's our first one that's diverged. They do diverge, just we haven't had a bunch of them. All right, so let's go ahead and do an E4, and I think E4 and P4 are our last ones. So I want the limit as j approaches infinity, right? I want the j plus 1th term. Well, that's going to be 2 to the j plus 1 over, and this is tricky because it's 2 times j plus 1 plus a 1 all inside the factorial. On the bottom, I'm just going to recopy the j term, right? 2 to the j over the quantity 2j plus 1 factorial. There's a lot to keeping these problems straight. Just it's a lot of little stuff. You need to make sure you have the limit. So this is going to be a 2 to the j plus 1 over, so this is 2j plus 2. So altogether, it's going to be 2j plus 3 factorial, right? I kind of ran out of room. Let's, well, we'll leave it this way for now because I ran out of room, and I'll fix it in the next row. Okay, so in the next row, oh, these are definitely the kind of problem where you sometimes turn your paper like landscape direction because it's just a lot. There's a lot of rows of fractions and things. So this is going to be a 2 to the j plus 1 over a 2j plus 3 factorial times, and then I'm going to flip this guy. So notice it's not an accident that I end up with the factorial on the top when the other factorial was on the bottom, right? So everybody ends up with a matching buddy. So I get that this is the limit as j approaches infinity. If I, sorry, I didn't mean to make it a 0 there, my bad. So this is a 2 raised to the j plus 1 over a 2 to the j, right? Those are the exponentials, this one and this one, times a 2j plus 1 factorial over a 2j plus 3 factorial, right? Well, when I clean this up, these guys are easy. They're just going to give me a 2 on the top, right? So this is the limit as j approaches infinity of, this is just a 2, because it would be 2 to the j plus 1 minus j. The j's cancel, and I get 2 to the first. And then for this one, it's helpful to recognize that this is a 2j plus 3 times a 2j plus 2 times, oh, there's the 2j plus 1 that I wanted factorial, right? So these cancel. So I'm going to get that this is a 2j plus 3 times a 2j plus 2. Well, that's a 0 because I have a finite number on top, right? This is finite. These are going to be infinite. When you divide a finite number by an infinite number, you get 0, so this thing converges. All right, last one, P4. All right, we're going to go ahead and apply the ratio test again. So with the limit as n approaches infinity of the nth plus 1 term is going to be 3 to the n plus 1. N plus 1 quantity squared, and an n plus 1 factorial on the bottom. The nth term is just going to be the exact nth term I was already given, right? I just copy it. So when I clean this up, I'm going to get that this is the limit as n approaches infinity of a 3 to the n plus 1, an n plus 1 quantity squared over an n plus 1 factorial times, and when I flip the denominator, the factorial lands on the top, the 3 to the n and the n squared land on the bottom. You don't have to rearrange it this way, but it really is easier if you put it so that everybody's with their buddy, right? The 3 to the n plus 1 is on top of the 3 to the n, right? That takes care of both of those. The n factorial is on top of the n plus 1 factorial, and the n plus 1 quantity squared is on top of the n squared, right? So when you do this, what ends up happening is you can basically treat it as 3 separate parts of the problem, right? 3 to the n plus 1 over 3 to the n is just going to be a 3, right? Because you do n plus 1 minus the n. These guys, I'm hoping we're starting to see, would just be a 1 over n plus 1, right? Because the n plus 1 on the bottom is an n plus 1 times an n factorial, right? And then these guys are just going to be a 1 as n approaches infinity, right? Because, so we still have the limit in front, so we don't have to do that. But this is going to be an n squared plus 2n plus 1 over an n squared, and really this is all I care about, and I could have anticipated that without foiling. So I end up getting that's a 1, right? So this ends up being the limit as n approaches infinity of just a 3 over an n plus 1, which is definitely 0. Since that's less than 1, this thing converges. All right, that is our video on the ratio test. We will revisit the ratio test again when we get to 1013. So that's it for 10.8.